Working on electronic equipment has many hazards associated with it that can cause injury and/or death. Please do not work on energized equipment unless you take proper precautions. Working on such equipment is done at your own risk and not at the prompting of information from this or any other YouTube channel. Hello and welcome back to Poor Man's Electronics Bench. This episode for working on my two Sencore LC53 units will cover the creation of a verified component calibration board to help with the recalibration of the two units once I have carried on with some other work. I will then spend some effort to get accurate component values recorded using a Leader LCR-740 bridge, a cheap TC-1 component tester, and my Brymen DMM 869S digital multimeter, which is still in warranty and calibration. More work will follow on the LC53 units on the next part. If this information may be of interest to you, please feel free to continue viewing. Hello and welcome back to Poor Man's Electronics Bench. In this part, I am going to try to get some calibration on at least one of the 2 meters that I am working on. I decided to get some capacitors I could use for general service for doing so, trying to get something with as close to a 1% tolerance as possible for the lower values and using them in order to gain a good set of calibration on the meters. Now granted, it's none of this is laboratory grade, and spending the money to send stuff out to get it calibrated by a lab is something on a meter this old would be probably about over $1,000, and the calibration might only be good for a year if that, so it's not really worth it for the work that most people do, including myself. So I just decided to try to get some fairly well graded components from a quality source. I'll check them with a couple of means, and then I'll use them to calibrate the meters. So in the meantime, I've got things like this little guy here, which you can barely see. It's 100 pico or picofarad at 1% COG NP0, so it should be temperature stable enough to use for some means for calibration. Another size up from there, I was just poking around on DigiKey and I found the 8200 pico at a 1% COG surface mount device. The only problem is it's an 0603. It is as tiny as all heck, and I'm going to have a heck of a time soldering this onto a board. So you get the fun to watch me struggle do that, because I don't work with surface mount components too often. So I think I'm going to start the festivities out with this one, in fact, and there's a good chance I'm going to lose this and I'll have to cut this installation short. I've lost components smaller than this before, bigger than this before, so I think it's just, these things are, for me, they're a hazard to work with. I can't say I'm really qualified or have a lot of experience of doing it, but yet I'm gonna try to pull it off. So one of my things I'm going to do is I do have a magnifying glass to use. I can probably pretty the lens up a little bit. Got a little dust on one side and a little grunge on the other. I got my board, which I'll try to get in a good spot here. Where can I? My finger's about right there. Okay. Not exactly the best quality lens. I do have that second magnifier in it, but I don't know how this is going to work with me looking through both at the same time. I might just give you a alternate angle view of what I'm doing while I'm doing it. I don't know how this is going to work, but going to try to prep this guy with some no clean flux and then go from there. If I had some paste, I'd use it, but I'm not a big fan of buying paste to keep on hand, mostly because it's got a shelf life, and even if you keep it in the fridge, there's no saying that it's going to keep with a good ability to be used by the time you get to it. Tweezers are a must. And I'm going to try to mount this one probably as one of the second capacitors to use, so I'm going to put some no clean flux on part of the board. This is a I can probably tin a couple of spots. Wouldn't be the worst thing. I'm probably going to try to go let's see here. What do I want to do? This is just well, it's not that I can't see what I'm doing, it's just that I've just this is just tiny work. I'm not really experienced with it as much as I could or should be over the years. I'll try to get this guy out of his package here without having it shoot onto someplace. I think it was a 1 gig. There it goes. I had a 1 gig resistor get away from me once. I'm not sure what's up or down in these guys, or if it really matters. Put a little no clean on the part itself, and gonna just hope like heck that I get it soldered down in place for some continuity. Oh crap. What did I say? I went to squeeze it and off it went. Unbelievable. I don't know if anything stopped it or deflected it. Found it. I had a monumental stroke of luck. I thought that thing went flying when I went to pick it up and I squeezed it too hard. It somehow stayed on the mat I was working on. I don't know how that happened. I just have to remember in the future not to be squeezing these damn things. And they are slightly magnetic, so I've got to also keep that in mind, because even a little magnetic effect of a stainless steel tweezers can pick the thing up and stick it to something, and the next thing you know you're looking for it and it's gone. I'll try to get some solder on this guy one side at a time. There are certain values of capacitors that Sencore wanted to see you use in order to do the calibration. It seems that most ranges switch over in the about a 100 or 1000, 90, 99, 99 count. 100 or 1000, so they wanted you to use 800, 80, 800, 8000 on a lot of stuff. Looks like I got it soldered on the board here. Then what I'm going to do is I made up some little loops for clips. There we go. I like to solder into this board on the top, and then on the bottom I'm going to put in a little bridge going from spot to spot. I don't need to have these be too long. Probably put some solder in the hole and just heat it up and drop it into where I want it. So you've got a little bit something better to clip onto. This iron should be giving me enough heat to heat the whole top to bottom to get this in here. I would think. There we go. Close the loops up on these, and you can see I made a loop, but just a piece of wire, so I'll get one in on the other side as well. And this component's the most amusing out of the bunch for putting on this board. The rest of them are going to be a lot larger, and I just have to mark them in some way, shape, or form so I know which one is which when I go to use them for testing. So I'm going to go ahead and populate the rest of the board with some components, and I'll come back in a little bit to show you the results. And now that I am done constructing my little printed circuit board, I'd like to introduce you to it and some other things that you haven't seen before. This is the results of my work. I did add another inductor later on to get a good value. The little guy here is a surface mount that's 82 microhenry. This is supposed to be 820. This is at 8.2, and it's supposed to be at 820. Or this is 8.2 millihenry. Then this is supposed to be at 82 millihenry. And then off camera here, I've got a couple of iron core guys. This one is supposed to be a 1 Henry iron core choke at 240. And they got another one that is a 9 Henry rated at 40 milliamps. And what I'm going to do is kind of try to qualify these things with a couple different testers in order to make sure that when I go to calibrate the LC53 that I am coming up with proper values on things. I'm going to go over capacitance first, and I don't know if you've seen this, but I'm going to feature this on this little part of the video. It's a Leader LCR-740 capacitance, inductance, and resistance bridge. It's a fun little unit. I picked it up a while back as an auction site purchase. It's in really nice shape. These are only powered by a 9-volt D cell, or it can be powered through external power. Get a jack on the front as well if you got a 9-volt wall wart. This mostly works off of a built-in 1 kilohertz oscillator, so everything it's going to do its measurements with is going to be based on an oscillator, and it gives you some adjustments in order to find your values. First off, you got a power on and sensitivity. You've got switches for your different ranges on your resistance, capacitance, and inductance, and it also has a function to use a DC bridge circuit to measure resistance with. There's a couple other functions. This one's called the DQ knob. I forget what the DQ acronym is. I can look it up in the manual. This helps you find what would be considered a dip or a valley in the settings when you're going to do your fine tuning to get your value on your calibrated potentiometer here. This is I think this is like a 100-turn potentiometer or something. It's a maybe a 10th turn. It's a really fine tuning guy, and it's calibrated to its numbers. And this one component here would be impossible to replace once it's worn out or broken. So keep that in mind if you ever see one of these on the market. This guy has to be in good working shape, or else you can pretty well crap can it, because it's hard to come up with a good replacement for it. They make some similar items, but I don't know what kind of quality they are and if they'd be a good substitution for it. I never had to investigate it. So we're going to use this unit. We're going to use a cheap model TC-1 tester. I just did a self-test on, and hopefully it's going to behave itself. Let me do an open reading on the leads just to make sure that it should come up with a low. Well, I've got a TC-1 multifunction tester off camera that was just working, but now it tells me it wants me to charge the battery on it, so I'm going to charge the battery a bit while I'm using the LCR bridge to get values on this guy and see how things work from there. So in the meantime, let's hook it up and see what kind of values I can get. My first is going to be, I've got capacitance. I've got a 100 pico farad there. I've got an 8200. This is a 0.68 micro, and we're going to see how this measures out the electrolytics. This is a 100 microfarad, and this other one's an 8200. It's not as good with the larger value microfarad capacitors, so I'm going to try the first one for the 100 picofarad. And one thing I did notice about this guy is you want to measure your zero on these really low value capacitors in this low range. I'll take a look at it. I've got my leads hooked onto themselves so they're not picking up any interference or anything else. Power it on. I gotta set this switch to X1. It tells you that if you have a hard time getting a dip or a valley, you can switch this to the X10 position. This RCL switch needs to be set to AC position. This can stay normal. And so right now I'm going to try to get what would be my inherent value in the unit just with the leads on here. I'm going to raise my sensitivity a bit. You see my meter has gone up quite a bit, and I'm looking to get a dip that's kind of in a valley between two peaks, and right now I can't get it with the X1 switch in this position, so I need to move it to X10. raise my sensitivity. And I'm still having a problem getting that. I don't think I'm going to get, since this is such a low value, but let's set this to 0 and see what I can do here. Okay, I'm getting a little dip or a valley right about there on my DQ, so I need to adjust this off of 0, and I am finding that I'm getting a low point there. I could raise my sensitivity up a little bit so I can see a finer adjustment. And there I'm getting the lowest I can on a dip or a valley on that adjustment. And what I am finding is on my calibrated dial, I've got about 2.5 picos with leads in it. If I pull these out, it might even be less. It dropped the whole picofarad, but with the leads we have about a 2.5er. So we're going to subtract that value from what I measure on my 100. I'm clipping onto the board. I'm going to lower my sensitivity so I can get my meter back to indicating something. And I've got a good dip right there, so I'm going to raise my sensitivity, adjust my compensation on my DQ knob, so that's about the best dip or valley I can get there. And I have that, and I'm coming up at about 103.5. So that would get me to it's minus 2.5, 101 on the LCR-740. I'm going to lower my sensitivity so I don't peg that when I move my leads around. Now I'm going to go to my 8200 value. If I'm looking for 8200, I'd have to go up in a high range of this and run this up to 8, or I can go about where I'm at. I could stay about where I'm at with that switch. So we're going to try that. I'm going to put this back down. I'm going to try to adjust for a valley here. Maybe that didn't help. And if you can't get a good dip or valley between peaks, you're probably in the wrong range for your adjustments. I got a little one right there. Let me go and try it in this range. Okay, in this range I am getting a dip between two peaks, so I can raise my sensitivity a little. That's about my best right there, and I'm going to, this will probably have to be adjusted up to about an 8, so I'm going to be raising that quite a bit until I get it close. Okay, it seems to be close right there, so let me use my DQ knob. And it's not behaving itself right there as well as it could. If I check and make sure I got these leads connected well. This bridge seems to be fairly accurate, but it's also touchy and time consuming to use, and that's about the best null I can get on that. Cranked all the way over. Oh, this one's really touchy. It's got a little dip, and once it goes off, it goes way off. This is also one hand on the unit and on the knobs only. And right now this is measuring out to about an 8130. Write that down. Okay, sensitivity down, we're going to go to a 0.68. I'm going to set it at, oh, we're close to that range already, so we're going to go to there. And this is the 0.68 microfarad capacitor, a bigger ceramic. Sensitivity's up. Get close to my value, and I've got a good dip there. Just a little, it's right in the adjustment range because I just got a little. If I touch this knob either direction, it goes up from there. So we'll just leave that there. And this is measuring out to a 0.677. That's a 0.68. This is a 0.677. I'll go for my electrolytics now. This is, like I said, these might not come out well, but okay, I know I have a 1000 microfarad electrolytic, so if I go in that range, capacitance, dial him down to about 1. Turn my sensitivity up. Got a good dip there. And this is measuring out right at about 1,000. 1010. I'm going to go with one qualifier on this. I have done this a few times over the past couple of days. Every day I've come back and these readings have changed a little bit. So there's something to do with humidity, room temperature, whatever goes on, static electricity, but there are changes that happen over time. I mean, none of these components in the test equipment are kept in a temperature controlled room, so it's got to be some variables, and it's probably maybe best to use something like this to check things out with your components just before you use them to calibrate something else. So I'm not saying how accurate it's going to be or not, but okay, this one should go up to 8,000. So I know I'm going to have to be raising this quite a bit because this capacitor is supposed to be 8,200. Got a good dip there. Every time you make a change with this knob, it'll change the position that this knob will also cause a dip. So you need to get the balance or readjust between the two as well as you can, because every time I get this one, I notice that I'm turning this up a little more. And I've got it about to the point where this sensitivity is at maximum now. That is my best dip. And my measured value on that 8200 capacitor is coming up about 7260. So those are what I have so far. The 100 is coming up to 101, the 8200 to 8130. 0.68 is pretty close, the 1000's close, and then that 8200 is a little low. We're going to use a couple testers as we go to check things out. Now we're going to go to inductors. Let me get my inductors to a point where I can turn my sensitivity down again, and we're going to go with the lowest value inductors first. So that's 10 microhenry. 100 microhenry should get me my value off my 82. And I shouldn't have to worry about checking the low end of the calibration on this guy. So right now, this knob's set in a pretty good position. Go for my best dip. Oh, we've also got to set this for inductors. Okay, we're going to raise this guy up. Got a dip right there, which is good. Raise my sensitivity. And that's got a really wide spread on it. I'm going to see if I can, what I can do to get that more sensitive. Okay, that's dialed in there. This is lowering my needle just a bit. One thing about these inductance measurements is there's false peaks I found. You can almost, I think I need to go to 10 microhenry in this range. That's right, I was in the wrong range for this high up in this knob. If you notice now I'm going up in value, I'll probably get a better peak and a more accurate reading like this. Or a better null, I should say. Okay, there we go. I changed this a lot. And then every time I change it, it's going to change how this reacts, but they have to be adjusted in tandem. It's coming up as a 98. That one I measured before is an 87. So that just shows you how much that things can go off on this for some reason. The connections are good. As far as I know, the switch contacts are all good. Yeah, it's still giving me my nulls on my same spot. Going to go try this guy in the low end of the 100 micro range. Gives me a peak and a null there. Peak and values there, so I've got a good value here. See, on this range it's coming up with a totally different reading, so it's the other one that was saying was closer to 100, where this is coming up in the 80s. Peg my meter again. Man, this thing is touchy on this valley. Okay, that is. I've got a 80, about an 81. Like I said, that one measured out the other day to an 87, so that changed 6 microhenries over the course of a couple days for no real good reason. And I don't think there's anything wrong with the battery in here. I can check it, but I really doubt if it's going low. I've been shutting it off in between uses as well. This next one is 800 in the 800 range of microhenries, so we're going to keep that about in the same spot. Got a good dip between values right there. Oh, I'm sorry, this must be 82 actually. Or 820. That's supposed to be an 820. Here we go. About an 83. It's about the best I'm going to get out of there. It should be 830. Okay, the next one should be an 8.2 milli. That should be pretty close to the same setting on the calibrated resistor. Wasn't that far off. Coming up as a 940, and previously it measured out as a 9.04. Now, for the two bigger iron core ones, switch them over to 1 Henry. It's a good valley there. Little change there. And that's coming up as a 1 Henry, is coming up as a 870 millihenry. That one I got marked on the side, and that one actually held its value, 870 millihenry. So that one's a good one. Something's up with those smaller ones. So I don't think it's a battery issue if that one's measuring out to be the right range of things. And then my 9 Henry that previously measured out as a 4, I can leave things in the same range then. Make sure my leads are separated. Lower my sensitivity. Got a little bit of a dip there. Okay, I got a good dip there, so see, if you notice, this is giving me kind of a weird indication because it's nulling out at a 0.6 Henry, which it shouldn't. So we're going to set this close to what I measured it at last, in the 4 range. Okay, I think I can get a value with some peaks right there. I do. I got one right there. A little bit more of a dip. Pretty good there. And that one's measuring out as a 4 millihenry again, or a 4 Henry I should say. So let me see, my TC-1 is back working again. A little low on charge, but so I've graded out everything I can using the LCR-740, so we're going to go through things real quick with the TC-1 just to see what kind of differences it may have. I can zoom in a little more on that guy here. Maybe prop it up with something. Okay. So this being a 9 Henry part, first off, let me, I was going to recalibrate it, but I don't think I need to. Okay, TC-1 says at 8.02 Henry. Which is interesting. Go with our 1 Henry that measures out to 870. Says it's a 930. And we'll go back to our board here. And get both of them in view. Go with the larger one in descending order. It's measuring as a diode, that's not right. Let's try it again. Measuring as a capacitor now, that's not right. And that's measuring as an unknown or damaged part, so excuse me while I do a calibration on it. Okay, try her again. This should be an 82 millihenry. Unknown or damaged part again. No, it's not happy trying to measure that one. I don't know what the deal is. We're going to go to the 8.2 millihenry. It says 8.09. Or 8.2 millihenry is 8.09. That's not bad. This should be at 820 micro. $890 micro. And then the little guy, the little surface mount should be an 82. Coming up as a 100. So I think I'm going to go with a bridge on that one. And then we're going to try the capacitors going up in ascending order. So we'll try the 100 for 100 pico first. 103. So that's pretty close. This one was a 8200 or a 8200 pico or a 8.2 nano. 8033. The next one is a 0.68 micro. .680, 1.7. This is pretty close. Here's the 1000 microfarad. Taking some power to test that. That one's coming up as 1023. So the screen kind of blanked a couple times looking for the power to charge that capacitor up, and then we're going to go to the 8200. $8,200 is testing it as a 8302. I'm going to run that one more time. $8,350. So that tester kind of grades it on the high side. Okay, we're going to get rid of him and get my Brymen 869S involved. Since it's a newer meter, it's still under warranty, and it should be also still be under calibration. So I can at least measure capacitors with it. That's what I'm going to do. I'm going to go to the capacitance range and set my display light on, and my 100 pico might come out as a 0.1 nano. Give it a minute or two. Oops, what if I connected to the right place? It's getting there. It's almost there. Come on. There it is. This shows you can measure up to that. Not to the greatest accuracy, but it's there. This was a 8200, and it's right at 8200. Next one is a 68, 684. And my video shut off for some strange reason, but I'm going to go over, don't know where it paused, but I think I can go over the last two capacitors again. This is the 1000 micro. They'll hook the polarity up properly. And as I was saying before, if it's set on the video, I need to count to about 10 after you get a reading to let it balance out. 3, 4, 5, 6, 7, 8, 9, 10. I got a 1049 before, and it looks like it's heading for that. Leveling off, so it's a repeatable measurement, which is good. And I'm going to try my 8200 micro again. It measured out at about 8200 after about 10 seconds. 1, 2, 3, 4, 5. Oh, staying at a low side. It's about 80, about a 80, say about 8050. So it's right over the 8,000 area someplace, depending on what meter you use and when you use it, how you use it. But that's about it for grading this board out for values, and I've got to double check that 9 Henry inductor one more time with the leader bridge. What I'm going to do is set this up to read out a 9 Henry. Zoom it a little more again. So it'll be set to inductors. Switch that on 10 Henry. So a value of 1, and this would be 10 Henry, which is about here. So considering that is supposed to be the known value, got my sensitivity up, and we'll see if we can get, there we go, you've got a valley in between two peaks there. Raise my sensitivity a bit. That's about the best valley I can get. See, I can't get a valley around the rated value of this inductor. So what that's telling me is it's at this frequency, it's not acting like a 9 Henry inductor. I've got a good value about right there, a good dip, so I'm going to readjust my DQ. And I got a repeatable measurement of a 4.0, so I don't see, it just depends on the piece of test equipment you're using sometimes, what frequency it's measuring inductors at, and it's going to change. But at this case, this is using a 1000 hertz, like I said, so I've got good connections. It's a repeatable measurement, so I can't see where that's an issue along those lines. So we're going to call these values and possibly check them one more time just before I use these components to calibrate with, but I'm not going to do that on camera. I'll just do a quick double check before I before I do the calibration on the LC53, and then we shall start to go over that in a bit. I am going to call an end to this part as it's ran for almost an hour, and I will cover more of working on the LC53 units on the next part, as I will be replacing capacitors and trimmer pots and attempting to calibrate unit number 1 using the component board I made on this part. Thank you for viewing. If you enjoyed the content, please give a like, and if you want to be notified of more, please feel free to subscribe. I hope you return soon. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.